Today we're going to go over factoring polynomials. So there's a few different methods that we're going to learn, and the first one that we're actually going to review is the factoring method difference of two squares, or how we like to call it, dots. So dots we can use if, one, it's a difference, so subtraction, and then two, if you have two perfect squares. So perfect squares for variables, that would be any variable that's raised to an even power, an even exponent. And then for numbers, you just need to know some of the first few perfect squares. So we've got 1, 4, 9, 16, 25, 36, and you can keep going on and on. So let's try. This is kind of a review from before. The first one here is 9x squared minus 49. So 9x squared, this is a perfect square. The square root of 9 is 3, and the square root of x squared is x. And then 49 is a perfect square. The square root of 49 is 7. Okay, that's just to remind us what they are. So when we factor this, we follow the pattern, and the pattern says that the first term goes first in both parentheses. So that 3x goes first. The 7, that second term, goes last in both. And then always one parentheses, one factor is a plus and one is a minus. And this is the pattern for all difference of two squares. Now, what if it's an x that's higher than just x squared? So now we're moving into polynomials, and it actually still works the same. First, we need to find the square root of each. For x to the fourth, the square root of x to the fourth is actually x squared. And if you need to figure that out, you just take the exponent and divide by 2, and that is how you find out what the square root exponent would be. So the square root of x to the fourth is x squared. The square root of 81 is 9. So we're going to get our factors. We've got x squared goes first, 9 goes second, 1's plus, and 1 is minus. Now that we have our two factors, take a second look. There's actually more that we can do because this x squared minus 9 factor is another difference of two squares, right? X squared is a perfect square, 9 is a perfect square, and they're being subtracted. So we can factor this one more. X squared, the square root is x. 9, the square root is 3. So we get x plus 3 minus 3. Now the x squared plus 9, we can't do anything because it's addition and not subtraction. And so we're just going to bring x squared plus 9 down, and here is our factored form. All right, let's try one more. Now this one has x to the 6th power and y to the 4th. Both are perfect squares because their exponents are even. And in order to find the square root, we just divide that exponent by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. We put this into our factors. X cubed goes first. Y squared goes second. 1's plus, 1's minus. And there's nothing more we can do. So that's a little review of difference of two squares, plus adding on exponents that are higher than 2. What happens, though, if we have an exponent of 3? What if we have a cubes problem? So the exponent of 3, we call that cubed. So a sum or difference of 2 cubes. So we can actually, for cubes, factor both the positive and the negative, if it's a sum or if it's a difference. And that always follows the same pattern. So I'm going to look at just the sum first, and then we'll see how that also is the same for the difference. We start with a cubed plus b cubed. So both a cubed, b cubed, they're perfect cube numbers. And that factors to, first, a plus b. So notice it's going to be the cube root of a cubed is a, the cube root of b cubed is b, and then always this sign is the same as the one in the original problem. Then the second one is a squared. Then we multiply a times b, and then we have b squared. And what you see here is this sign, this next sign is always opposite of the sign in the first parentheses, but this sign here is always positive. So let's just look at the difference. I know it might be hard to think about it conceptually, so when we get to an actual problem, it might be a little bit easier. But just let's look at it real quick. So we have a cubed minus b cubed. So our first parentheses is a and b with a minus, because remember that stays the same. Then we have a squared plus opposite a times b plus always positive b squared. So this is the pattern that we're going to follow. Let's actually try to apply it. So for the first one, x cubed plus 8. This is going to be a sum problem. So I'll try to leave that sum pattern up for us. X cubed is a perfect cube, and 8 is also a perfect cube. If we have x cubed, that is a cubed. That means that for us, a is x, because that's the cube root of x cubed. And then we have 8. 8 is b cubed. Well, what number cubed is 8? That would be 2. 2 cubed is 8 because 2 times 2 times 2 is 8. Now we can fill in the pattern. So we start with a and b, a, b, and then it's going to be the same sign as the problem. So x plus 2, a plus b. In the next parentheses, it's a squared, so x squared. Then the sign is opposite, so minus. And then we multiply a times b, so x times 2 is 2x. This final sign is always positive, and then it's b squared. 2 squared is 4. And there is our factored form, just by using the pattern. Let's try a difference problem. We have x cubed minus 64. The cube root of x cubed is x, so that means a is x. And the cube root of 64 is 4, so that means b is 4. We're going to put this into the pattern. So we start with, because this is a minus problem, a difference, it'll be a minus b. So x minus 4 times a squared, so we get x squared, opposite sign, so we get plus, a times b would be x times 4, we get 4x, and then always positive, b squared is 4 squared is 16. There's our factored form. All right, we have another one here. Now this one, there's a coefficient in front of x cubed, and that's okay as long as it is also a perfect cube. And it is. 27 is a perfect cube. So for this first term, if a cubed is 27x cubed, then a is going to be 3x, because 3 is the cube root of 27, and x is the cube root of x cubed. Now for 1, the cube root of 1 is 1. So now we can put this into our factored form. In the first parentheses, we have a, and then it'll be plus, because this problem was a plus, b. So we get 3x plus 1. Now in the second parentheses, I'm going to use some, I'm going to actually take 2 steps here. Next, it's a squared. Now, a has parts, right? It's 3 and x, so I'm going to actually use a parentheses here. So we're going to do 3x squared minus a times b will be 3x times 1. Always positive plus 1 squared is just 1. I just want to show you, in case you maybe would get lost here if I skipped a few steps. We have that 3x plus 1. Now, when you do 3x all squared, remember you have to square both the 3 and the x. So this becomes 9x squared. Minus 3x times 1 is just 3x. Bring down the plus 1. Here is our factored form. Now, to help you remember this, one tip that you can think is SOAP. And SOAP stands for same sign. So this sign and this sign are the same. Opposite sign. This sign is opposite of the original. And then always positive. SOAP. This last sign is always positive. So if you need help remembering the signs, you can think SOAP. Same, opposite, always positive. All right, so now the last one we're going to do in this video is factoring using the big X method, which is partially review, but it's also actually a little bit new because we're going to extend it past just x squared. We can also factor big X for trinomials with powers higher than x squared. Now, in order to do this, it is important. The leading term, that leading term right here has to have an exponent that's even. That's rule number 1. And then rule number 2 is that the middle term's exponent must be half of the biggest exponent. So like 2 is half of 4. That's the only way that you can do a problem like this. If that is the case, then we can set up big X. Still, C is on top and B is on the bottom by itself. I need two numbers that multiply to 28, but add to 3. Well, 28 is 7 times 4. And if I make 4 negative, then negative 4 times 7 is negative 28, and negative 4 plus 7 is 3. Now, when we get our factored form, it's not just x minus 4 and x plus 7, because we have an x to the 4th. So these two x's need to multiply to x to the 4th. Therefore, they will be x squared instead of just x. Now, a trick is that whatever this exponent is will be the exponent that these two x's get. So whatever is that exponent on the b term, that will be the exponent in your factors. And then we've got minus 4 and plus 7. We're not quite ready to be done with this problem yet, because what you might notice is that now in our factored form, we have created a difference of two squares problem. We can do dots here. The square root of x squared is x, and the square root of 4 is 2. So when we factor using dots, we get x first, the 2 comes second, 1 plus, 1 minus. Now, x squared plus 7 is not a perfect square, and it's not a difference, so we can't do anything else. We're just going to bring down that x squared plus 7, and there is our factored form. Now, for example 2 here, again, I can do the big X method because 6 is even, and 3 is half of 6. So we can set up our big X here. 24 is on top and negative 11 on the bottom. Two numbers that multiply to a positive 24 but add to negative 11 are 8 and 3. Negative 8, negative 3. All right, when I set up my factors, remember that x is going to have the same exponent as the middle term. So we'll get x cubes. We've got x cubed minus 3 and x cubed minus 8. All right, we're not quite done yet here because now I have some cubes. Would either of these be a difference of two cubes problem? This one would be, because 8 is a perfect cube. So we're going to factor this using the cubes method we just learned. The cube root of x cubed is x, so a is x. The cube root of 8 is 2, so b is 2. It is a difference, so we'll have a minus b, so x minus 2. And the second parentheses is a squared, so x squared. Then it's the opposite sign. A times b is 2x, always positive sign. And then b squared, 2 squared is 4. Now, x cubed minus 3, 3 is not a perfect cube, so we can just bring this down. Don't forget it though, because it is part of your final answer. This is our final factored form. Take some time to try your homework. Hope this video helped.